Okay. So howdy. Let's start. I know that my talk it's gonna be somehow different to the rest of the tracks in this conference. That's basically because, this is cloud computing, whereas the rest of the talks are more like big data focused. But still, there is an important link between both technologies. So well, let me begin from the beginning and introduce myself a little bit so you can put the rest of what I'm going to be telling today in context. Well, I'm an engineer. Not that I'm working as an engineer any longer, although I like to. Nowadays, I'm facilitating or managing teams that build a scalable technology, along with the, with the deployments of that technology as well. I'm also a really big open source enthusiast. And I do believe you all know what that is. I mean, there is huge advantages about using open source. Just, think of this. When things get really, really rough, you are only in control of your fate if you can basically dive into the source code, figure out what's failing in there, and having the possibility. I don't say you have to do it, but you have the possibility of fixing up whatever it's broken. And that's fundamental for a lot of environments and basically businesses. So that's it. I mean, you'll see how I give a lot of importance to open source, and I'll keep saying once and again that this is open source, and that that adds value to the whole mix, and that's basically the reason. So, without further delay, let me start introducing. And I know you already know about this, but let me talk a little bit about what is my understanding of cloud computing. Cloud computing is basically moving away from a paradigm where computing was a product to one where computing is a service. And that's all. There are a lot of people talking about elasticity, about a ton of different things, and that's supposed to be part of cloud computing. They might or might not be right, but this is how I understand cloud computing. Cloud computing is computing as a service. And this is an example I usually put. In the past, whenever you wanted to have electricity, you had to, to take one of these generators, and well, first thing you had to invest on the generator, you have to install it, you have to fuel it, you have to service it, and then you could have electricity, right? And this is what we've been doing with computing until recently, right? I mean, we wanted to have compute capabilities, and we had to buy hardware. We have to buy stuff and do a number of different things before we could actually do what we wanted to do with it. All that changed, and what happens now is that we have electricity as a service, right? I mean, you go, plug to the grid, and you are done and dusted. You have everything you need, and you don't even think about buying a generator and getting on all that messy process, because there is no need. You have different companies that provide you that service, and you just use it. You don't have to worry about it. You don't have to do anything. You just use it. At the end of the month, you pay your bill, and you keep going. So cloud computing is basically the same thing. Instead of electricity or water or internet connectivity or whatever, you pay for compute capabilities, and that's it. So all this started because virtualization was brought to the table. And again, I know you guys know everything about this. Let me go really fast over this. Basically, what happened is we moved from an S scenario where we had an operating system on top of every single box we had in the data center to one in which we have bigger servers, and they can hold a number of different instances or virtual machines inside of them. That happened because the microprocessors started implementing a set of instructions that enabled all this to happen. Nowadays, even the cheapest laptop you can buy in the supermarket is got that set of instructions. So this is taken for granted. There is a number of advantages that comes with this. For instance, fault tolerance. You can do height availability much more easily in this sort of environment, and that ends up providing a much more stable environment for running applications on common development. And also there is this capability of doing stuff on the fly that didn't happen before. What we had, nobody had, I mean, not everybody had that, but what we used to have is you could provision bare metal servers on the fly in the past. That was doable, and some people did. But with this sort of virtualization, you can do whatever you want. I mean, it's really snappy to create a VM with whatever operating system you want, with whatever size, with whatever flavor of apps installed you wanted to put. That will happen within seconds, and then you are ready to go. So this again is an improvement over the previous scenario. There is another example about this, and that is how we treat the servers. And I'm pretty sure you guys have seen this example, but I believe it's worth going through this again. So in the past, we used to treat servers as pets. Whenever your dog gets ill, you nurse it, you try to get him back to health. You pay whatever it's needed in medicine or whatever he needs to get him well again, right? But that changed. Nowadays, especially with cloud computing, you treat servers as cattle. That means you give them a number, and whenever some of them get ill, you get ready to buy another one. You don't care. You will dispose that one as bad as it sounds, but you don't even care about healing the cattle. You go buy another one and put it in place, period. That's it. And that's what's happening with servers, and especially with virtualization. If something is going wrong with one of your instances, you put another one in place, the load balancer will take care of it, nothing happened. And that's an important change as well. Actually, I guess you all remember when we gave servers names, right? Like whatever, I don't know, NBA players or The Simpsons or whatever. That doesn't happen any longer because there is no need. We have so many of them that it could be nonsense to try to find a set big enough for doing that, right? So it's basically a shift in the understanding of how servers are treated. And again, now we move faster and we can do things that we couldn't do in the past. Another important point here is how we utilize the hardware. In the past, whenever a server was idle, nothing happened. Your mail server, sorry. It's basically idle. There is no mail going in or out, but the server was running there. In this scenario where we have virtualizations in the server, we can instance as many VMs as we want until the server is properly utilized. And that doesn't mean that we have to check them and keep tracking what's happening within the server. Something like OpenStack will take care of this. And I'll explain to you how this happened later during the presentation. But all this orchestration and all this scaling will happen magically, if you want. And the servers that are being run will be fully utilized. Well, a direct consequence of this is the cost. It's much cheaper to use something like this than to have, a full rack running for basically nothing. So again, this is again, sorry, this is the elasticity that I mentioned before. You can reprovision servers, you can make them scale with basically no cost. So that was for the introduction to cloud, but what I wanted to talk about today is the open cloud, which is the same concept with a few extra properties. In this case, I'll be focusing on OpenStack. OpenStack is all about freedom. And once again, I'll use a really common example about freedom as in beer, or free as in beer, or free as in freedom. In this case, we mean both. OpenStack is all about freedom. It doesn't cost anything unless you want to pay a company like Red Hat for it, and there is really good reasons for that. And the code is free software and open source. I'll be talking a little bit about that later on. But basically, you can grab whatever component you want. You can modify it. You can deploy it. You can resell it. You can do whatever you want as long as you maintain the same license and provide the same rights that were provided to you in the past. An important consequence of that is that there is no lock-in. No company will keep you under its wing against your will. If you want to use OpenStack by yourself, you are more than welcome. And actually, I encourage you to do that. If you wanted to pay whichever company you want for support, it's awesome. In case that company didn't provide you the service that you expected, you can move to another one, because there is, and I'll be talking about that later as well, but there is 150 companies backing OpenStack at this stage. 150. You will get what you want. One of them, whichever it is, will provide you exactly what you want. And then, well, we have interoperability. That means that we are trying to use in the development of OpenStack as many standards as possible. There is no point trying to reinvent the wheel when there is something done already. So we are reusing technology, and we are using as many standard protocols as we can. So getting a little bit more into details, OpenStack is a platform for building infrastructure as a service, clusters, if you want. It's everything from the first to the last bit is free software released under the Apache license. It's a fairly flexible license, so it shouldn't be a problem for anybody. You could even take a piece and make it non-free, and it will be fair enough. I don't say you have to do that, because there is no point. That could be against your interest, but you could do it. It's completely implemented in Python, which is, if you ask me, pretty cool. It's a straightforward language. It's easy to code in. A lot of people know it. It's easy to read. It's easy to fix, and we can do things fairly quickly in Python. We have a 6 months cadence release cycle. That means you'll get a new OpenStack twice a year. I'll be talking a little bit more about how that happens, but basically that doesn't mean that every 6 years the whole thing will get unstable and you'll get in trouble if you try to upgrade. We have a great development methodology that I'll be introducing as well. And what it does is we make sure OpenStack is stable from release to release, and no regressions are being introduced. Or maybe they could in theory, but it's really tough with all the QA that we have in place already. It's run by individual contributors, so even if there are a whole lot of companies around the project, the people who actually do the stuff are the people in power. Whenever a change is proposed to OpenStack, there must be somebody else, some other developer, who evaluates whatever you did and votes +1 or +2, so it can be integrated. So everything is reviewed and people make the decisions. There is no company, there is no, super powerful entity there that can say this change aligns with my agenda, so I'm approving that. That doesn't happen. It's the people who actually work in the project, the people who vote and drives or steers the project. As I said, we have a really solid development model, and this is something I foresee other projects incorporating in the future or adopting in the future, because it's proven to be really useful. In the past I've been involved with a number of different fairly successful projects. I'm a GNU developer. I used to work in GNOME. I was part of OpenSolaris and OpenJDK, founded the Cherokee web server, and I've seen a whole lot of different things and development models, but this one is by far the best one I've seen. It's solid. It takes care of quality. Quality is right in the center of this model, and the development speed is fairly high for having all those quality measures in the middle. Oops, sorry. Seems I didn't notice that. Last point there could be the OpenStack Foundation. The foundation is there as the legal entity backing up OpenStack. There is a board of members who are voted every year. This is basically something we need it from a legal point of view. But at the end of the day, people working on OpenStack are the people empowered to steer OpenStack. So how was OpenStack born? Basically, it was NASA plus Rackspace in 2010 who met and realized that they were working on something really similar. They wanted to have something like OpenStack, but they didn't know that they were implementing something really close. NASA implemented Nova. That means the hypervisor, scheduler, the volume support, and the networking, or the first implementation. And Rackspace implemented Swift. Swift, as we will see, is a generic object storage. A pretty interesting one, actually. So they saw they had common targets. They wanted to have the same thing, and they figured, why not? Let's collaborate on this. And that collaboration ended up being a really big success. So the first release happened a few months after that, in October 2010, and since then, we've kept improving that basic project and making it grow, and enhancing and adding new features. Couple of weeks ago, we released Havana, the latest release, and well, as you'll see, it's been. I don't think it's correct for me to say this, but it's been a really major success. It's right. So, said that, OpenStack isn't the only open cloud project. There are more out there. However, I do believe it's the most important one, and for that I brought you a few graphs representing different metrics on this. So this is the active participants in the different communities, in the open source communities. As you see, OpenStack is the blue one, and closest competitor would be CloudStack in green. But it's, it's the difference is huge. And what this means is, if the trend continues like this, within a few years, they will have nothing to do with each other. I mean, OpenStack, it's positioning itself in such a good place that, geez, I mean, you basically check it out and make your own opinion. This is the size of the communities, the global size of the different communities. In this case as well, OpenStack almost, well, actually doubles the closest competitor. This is people who are active in the different communities. If we checked the development community, something like that happened in that front as well. We have OpenStack. This is the number of commits or the number of changes merged in the different trees in a month. And once again, in the case of OpenStack, the difference is huge. You see that there is a few spikes there. That's because whenever a release is approaching, we try to process as many bug reports as possible. And last but not least, we have people contributing code. This is the people who are developing and fixing bugs in the source tree. Once again, OpenStack is skyrocketing, and it may be me, but if I had to go with one of these technologies for my company, I could know which one to choose, because at the end of the day, the future is going to be implemented by one of these teams. There are a whole lot of people gathering together in one of those teams, in the team OpenStack, doing great stuff. So before I move forward, I wanted to talk a little bit about the releases and how they are named, because I'll be mentioning some of these later in my presentation. This is not important at all. Basically, the releases are named after consecutive letters. So in this case, GHI, and that, the name is chosen by something close to the venue of the OpenStack Summit, in which the release was planned. So today, the OpenStack Summit is happening in Hong Kong, and there is this street in Hong Kong named Ice House, and that's the name of the release. The previous one happened in Portland, in Oregon, and there is, I always have to read this, an unincorporated locale. I don't know what that is. It seems to be like a piece of land with some special laws, something like that. I don't think we have that in Europe. But there is this place called Havana over there. It is not Havana in Cuba, but in Oregon. And so since the OpenStack Summit was held there 6 months ago, the release was named Havana. The previous one, Grizzly, after the bear in the state of California's flag. And and it will keep working like this. So whenever I say Havana, I mean the latest release, and iHouse is the upcoming one, the one that we'll get in April next year. So moving on to the OpenStack architecture. And here is where I'll get a little bit more technical, not too much. So let me begin from the beginning. Let's see. No, I'm kidding. But that's actually the architecture of OpenStack. And that's something that the engineers working on OpenStack must understand. I mean, OpenStack is a fairly big and complex piece of software. But we don't have to go through this. So this scheme is basically the same thing. What I want you to take from this is not the relations or anything like that. Basically, OpenStack is a set of components with a specific functionality, and they communicate with each other through either message queues or web services, depending on the information that they are sharing. And that's basically it. I don't want to get into the details here. So these are the different components. Everything is really modular for a reason. We used to have, we used to have, for instance, I don't know if you can see the pointer. It doesn't work. In the past, we had another component for the networking, the virtual networking. But we changed it in the latest release, because in the one before, because this newer one was better and stable enough for us to show up. So that's one of the advantages of making the whole architecture really modular. We can develop in parallel, better components, and in case we wanted to replace them, we can, and the whole thing will keep working. OpenStack, and that's basic stuff here, but it's being designed to be really scalable. It must scale out. It must be really easy to pixie boot, a bunch of servers in your data center, deploy Nova computing there, and grow your cluster within minutes. And as a matter of fact, that happens. It works properly. Also, this set of modules or components are the standard components, but there are more that are being added. So over the time, as we keep enhancing the project, a new set of components will be added to the mix, adding new functionality. So let me go really quick through this and speak a little bit about each one of them. Keystone would be the first one. Keystone is the component holding or storing the information for users, tenants, roles, and so on and so forth. It also has the ability of enforcing policies in the cluster. So who can do what? And the different components check against Keystone whether or not they are allowed to do something specific. And it also holds the service catalogs. So since the different components must know what other functionality you have in the cluster, talking about components, they have to reach out to Keystone in order to know, well, this guy has whatever, an image repository, and if so, where is that? So that that's on Keystone plate as well. As you will see, all the different components have usually a number of backends, of different backends, because we all have different needs. And so, I may be willing to use SQL for this, whereas, some of you wanted to use LDAP and some other people wanted to use a key value store. So that's for Keystone. Next one would be Cinder. Cinder is basically where block devices are handled. That means basically hard drives. So in this case, these volumes are independent from the life cycle of the virtual machine. You may want to spawn a VM using certain hard drive or volume, kill it, but the volume will continue there in case you wanted to spawn more VMs using the same base operating system. Once again, there are different backends, GlassRFS, NetApp, EMC, whatever. There are a whole lot of them. All the major vendors usually have backends for all these OpenStack components. Next one would be Neutron. Over there you can read Quantum. Quantum was the former name. We had some legal issues with Quantum, and so we renamed the component to Neutron. Neutron is the the component that provides the networking API to OpenStack. All in all, I mean, this is a fairly complex component. I would say the most complex one. So, in a nutshell, what Neutron does is to decouple physical and the physical view and how can I put this? And the logical view of the network. And nowadays, networks are virtualized as well, so you don't need to have switches. I mean, you can have them, but you can have virtual routing and tunnels and a whole lot of things, everything managed by OpenStack itself. So that's basically what Neutron is doing. It's connecting VMs. It's allowing them or not to get to whatever gateway you have to the internet or whatever you want, and that happens independently of the physical network that you have in those servers. I mean, that's something you can configure. Once again, different backends: OpenFlow, Linux Bridge. There is, as for vendors, you have Cisco, you have Forsten, you have all of them basically. So next one would be Swift. This is the component that Rackspace came up with at the beginning of the project. It's an object storage. You can put information in there and retrieve it with a REST interface. Quite handy for a lot of things, and it's especially important how it scales and the replication that it supports. So I'm gonna speed up a little bit because we have just 5 minutes. Glance basically is the components holding the base images for your VMs. So if you wanted to have a Fedora 19 image, you'll put it in there. Glance will take care of the image independently of the format and the container type, and it will index the metadata. So and the rest of the components can use it. Nova is the heart of OpenStack, is the layer that handles the hypervisors and basically communicates with the rest of the components. I mean, if you wanted to connect a hard drive or a volume from Cinder, Nova could be there to to do that for you and enable your VM to have that capability. Once again, a whole lot of different backends: KVM, Shen, QEMU, VMware, whatever you have. And last but not least, we have Horizon. Horizon is the user interface. It's actually split in two parts: the framework, which allows to develop different interfaces, and the Django-based application that we wrote for this matter. It's not bad actually. And so, as an example of how the community is using these different backends, I just wanted to show you this really quick. It's different options. This is a survey that we did a few weeks ago on what the community is actually using the different backends. And as you see, LVM for the storage, Puppet for deployment, Open vSwitch for the Neutron backend, KVM for the hypervisor, as it couldn't be otherwise. The identity, Keystone, is using SQL, most of the cases, and operating system, Ubuntu plus the Red Hat systems. So the community, and this is one of the most exciting parts of the OpenStack project, because it's a truly amazing community in so many ways. It's the growth speed is unprecedented. It's I've never seen something growing this fast and this stable. The development model, as I said, it's something remarkable. And well, let me show you that really quick. Basically, well, most of the projects are hosted in GitHub. There is no reason for do something different. We used Jenkins for the QA. Gerrit, I don't know if you are familiar with the tool, is basically a web app where you can vote for patches, for getting patches merged or getting them rejected. Like, if you have a reason for a patch not to make it to the tree, you go there, you vote -1 and give a reason, like I would prefer this not to be merged because of this, and that. And the community will take that into account. The patch won't be merged, and the original developer usually will get it worked out for you and propose a new patch. That means that, a lot of eyes are checking the code, and that's pretty cool, stability-wise, let's say. So some numbers on how the project has been growing. That's from release to release. In the last 2 years, the number of authors grow, well, basically tripled. And same with the number of commits of changes made in the source code. Once again, I mean, if you've seen something like this, because I haven't. I mean, this is quite impressive. In this case, this graph represents the number of companies involved in the development. Once again, we almost tripled the number of companies in the last couple of years, and the trend continues. I mean, if check out pictures from the Ice House Summit right now in Hong Kong, and you'll see how that is. It's massive. Once again, it's pretty cool. And inside this set of companies, I wanted to show you something that I believe it's important as well, which is how much different companies contribute to OpenStack. Once again, I know you know this already, but if you wanted to get something support or commit your platform to one of these OpenStack distributions, you should know how relevant the company is in the development, because that will be reflected on the quality of your distribution. And actually, if you needed support, the company with the most commitment to the project is usually the one with more engineers and more know-how, and basically the company that will give you the best support. In this case, Red Hat, we are the company contributing the most. This is in the last 3 years. I tried not to cheat, so this graph was generated yesterday. So it isn't something old or anything like that. It's something that this is happening today. And as for the latest release, it's even more impressive. That's the number of bugs closed or resolved by different companies. Once again, Red Hat is way out. It's by far the company that contributed the most to OpenStack. And truth be said, I'm really proud of that, because that's the people I'm working for. I mean, my guys did this, and that's pretty cool. And so I'll go really quick through this. All right. So I wanted to let you know about RDO. RDO doesn't stand for anything, but you could understand that it could be like Red Hat distribution of OpenStack, maybe, I don't know. But officially it doesn't stand for anything. So what is an OpenStack distribution? OpenStack is a project focusing on the source code, but it doesn't try to integrate, install, or deploy OpenStack, or for that matter, provide applications to do so. Sorry. And OpenStack is a distribution, a set of packages for OpenStack for the Red Hat operating systems. And by that I mean Red Hat Enterprise Linux, CentOS, Scientific Linux, and Fedora. So if you are using any of those, you can go to openstack.redhat.com, and you'll find the instructions there. Installing OpenStack was a really tough process, and a year ago I know people who needed a full week to get it installed. I mean, as I said, it's big, it's really complex, and it's also powerful. But the installation was tough. So in this case, what we got to is a 3-steps installation. You have to go install a single RPM with the sources that you will need, install another package called Packstack, and then run Packstack, and that's it. Once again, I don't want you to think that I'm somehow tricking you, making you believe it's easier than it actually is. So this is the actual instructions that you have to type in order to get OpenStack fully deployed. It's gonna take like 3, 4, 5 minutes, depending on the server, or you can install it in your laptop. There is no problem. Or even, you could create a VM and do it inside if you wanted to, if you didn't want to mess up the distribution. But again, everything is in packages, so you could get rid of it and with no effort. And so I've been seeing signs about I'm running out of time, so that's basically it. Thank you very much, and if you have any question, take it.
Okay, do we have any questions?
Hi. I was wondering if you wanted to try this out, how is the smallest deployment that makes sense to learn and play with it?
In Packstack, we have an all-in-one parameter, so you can install it in a single box, and it's fair enough.
But you can test every component and see how it yes. Okay.
Yeah, I mean it's gonna be simple, like the network layout. It's gonna be really simple, but yeah, I mean that's fair enough for testing everything and giving it a try. Actually, I encourage you guys to do so. I mean, it's gonna take you half an hour, 1 hour to play a little bit with it, and you'll have a much better understanding of what I've been talking about. I know it's been a lot for 40 minutes.
You've spoken about the number of companies backing OpenStack and the number of developers. Do you have figures for the number of users, actual users?
Yeah, I believe I saw the graph. Let me.
Is instances deployed or something?
No, not for the instances. Oh, you mean like people actually using, not the. Oh no, I don't have that. I don't think anybody does. I mean, the thing is, it's open source, and there are companies deploying it. There is no way to track how many deployments there is out
I
there.
imagine that you could add the figures for Rackspace and for some other suppliers, big suppliers. It's just to check if it's also exponential or not, for curiosity.
I do not know.
Okay, thanks.
Sorry.
I have a couple of questions. One is what are the public clouds providers that are supporting OpenStack? Is Amazon's Rackspace? Are they supporting it partially, or at least because Chef Puppet at least are supported, or not even that?
So I'd say that the two biggest are Rackspace, one of the founders, and HP. DreamHost is also betting big for OpenStack nowadays. I would say those are the three biggest. Amazon is, of course, in the other side of the spectrum here. We are basically competing against what Amazon did.
Because that will be the issue. If either you go to the public or to the private or to the hybrid. So if it is not using the public cloud, it is maybe a product more for private clouds.
It's for both. I mean, there are big players providing OpenStack, like DreamHost and Rackspace. HP has got a big cloud as well. But I mean, you can go the model that you fancy the most. I mean, you can have it installed in your network, and then make it hybrid whenever you have the need, or go public all the way. It's up to you.
Any more questions? Okay, I think we are done. Thank you very much, Alvaro.
Thank you.